This problem is related to the concept of aldol condensation and Caninaro reaction. So problem says complete reaction of acetaldehyde with excess formaldehyde upon heating with concentrated NaOH solution gives P and Q. So acetaldehyde is completely reacted because it says complete reaction, and it also says excess formaldehyde. This means more than one molecule of formaldehyde has reacted with acetaldehyde. Furthermore, question also says compound P does not give tolerance test, whereas Q on acidification gives positive tolerance test. This means P does not have an aldehyde group, but Q has an aldehyde group, that is, it contains CHO group. Treatment of P with excess cyclohexanone in the presence of catalytic amount of para-toluene sulphonic acid gives product R. So when P is treated with cyclohexanone, it gives R, and it also says excess of cyclohexanone. This means more than one molecule of cyclohexanone has reacted with P. Furthermore, it says catalytic amount of PTSA. This means this is not participating in the reaction as reactant or as product. This is a catalyst. So you can safely ignore while writing the reaction product or reaction mechanism. You have to find sum of the number of methylene groups, that is CH2 groups, and oxygen atom in R. So how many CH2 groups you have and how many oxygen atoms you have in compound R. So let us try to solve this problem. So what are the hints that we have? The first hint is P is not an aldehyde. This means it does not have an aldehyde group, CHO group. But Q gives positive tolerance test. This means Q has a CHO group. Now further hint I have, that is we have NaOH. NaOH can act as a base or it can act as a nucleophile. It is reacting with acetaldehyde, that is CH3CHO, and CH3CHO has acidic hydrogen. So this means another hint I have, that is acid base reaction. Of course NaOH can act as a base or it can act as a nucleophile. If there is a chance of acid base reaction, first acid base reaction will take place. So let us try to write the mechanism. So we have acetaldehyde, so this molecule is acetaldehyde CH3CHO. Now it is reacting with base OH minus, and this OH minus is coming from NaOH. Now this hydrogen is acidic. Because of this carbonylic group, this alpha hydrogen becomes acidic. Now OH minus is a base and it will take this H plus and it will form H2O molecule. And at the same time this bond pair will come to this carbon and it will form a carbanion. So now I have a carbanion and a water molecule. Now this carbanion will react with formaldehyde. So this is the formaldehyde. It also has a positively charged carbon. This oxygen basically pulling all these electrons towards itself, towards its side, then this will have delta plus charge and this will have delta minus charge. So this carbon can be attacked. So now this molecule, that is the carbanion, can act as a nucleophile and this carbon will attack on this carbon. So basically there is a carbon-carbon bond formation. At the same time this bond pair will come to the oxygen and a negative charge will appear on this oxygen atom. So now I have this molecule. Now the next step, this O minus can take H plus from water. So this O minus can take H plus from here, and this bond pair will go at oxygen atom and it will form OH minus. So basically OH minus is used in the first step and it was returned in the last step. And what I have now, here this side I have an aldehydic group and this side I have an alcohol group. Now what will happen next? Now see, what has happened initially, if you see this, what has happened? If you see, this molecule was initially here, and on this molecule at this carbon one hydrogen is removed, and at this hydrogen what we have CH2OH. So this carbon and this carbon is same. So here I have hydrogen and here I have hydrogen. So two hydrogen. Here also I have two hydrogen. But one hydrogen is missing, and in place of one hydrogen what I have? CH2OH. So what I have done in this whole process, one hydrogen has been removed and it has been attached by a CH2OH group. Now the same thing can happen once again, and I can remove one hydrogen and I can add CH2OH group. So basically this process can happen two times. So I will remove one hydrogen here from here and I will add CH2OH group, and another hydrogen and I will add CH2OH group. So I have removed one hydrogen, added CH2OH group, and here also one CH2OH group. Now we don't have any acidic hydrogen on this carbon. So what will happen next? So now OH minus cannot get one proton. Now OH minus will act as a nucleophile, and as a nucleophile it will attack on formaldehyde molecule. It will attack on this carbon and this bond will open, so oxygen will have a negative charge. Now if you remember, at this place you will have Caninaro reaction. So OH minus will attack on this carbon and this bond will open, and this molecule we have. So this is a product of the first step. Now you see what will happen. On this carbon we will have a OH group, and in this oxygen we will have a negative charge. Now in the next step what happens? Something called hydride shift. This oxygen electron, that is this lone pair, will push here, this will come here and it will form a double bond. At the same time this hydride will shift onto this carbon, and at the same time this bond will open. So this whole process, something like this electron is pushing and this is forming a bond, this hydride is going and this bond is coming as a lone pair. So the product of whole thing is this, I will have a double bond, so single bond will become double bond, and at this oxygen I will have a double bond, and this hydrogen and oxygen OH, but medium is basic, so that's why this will not be finally as acid, this will remain as a formate ion. And this side we have this CH2OH group, and here I will have OH and here I will have H. So basically this is the oxidation reaction, oxidation reduction reaction, disproportionation reaction. So this has become OH and this becomes acid. Now see, this has a CHO group, and that's why this will give positive tolerance test upon acidification. So this must be Q. And then this does not have a CHO group, so this means this will not give positive tolerance test, so this is P. So now I know the structure of P and Q. Now compound P, which is one carbon, CH2OH group, CH2OH group, CH2OH group, and this is also a CH2OH group. So on one carbon we have 4 CH2OH group, and when this reacts with cyclohexanone, so what happens is you remove one H2O molecule, so this forms acetal. So from this side So you can remove one H2O. So this oxygen, hydrogen, hydrogen. So you can remove H2O molecule and you will form a bond. This side also you will remove H2O and you will form a bond. So I am not showing the complete mechanism of this step. This is a acetal formation, and this you can refer in any text, the mechanism of this reaction. But in short, you have to simply lose one molecule of water and you have to make bond between this oxygen and this carbon. So what will happen? This oxygen will be connected to this carbon, and this oxygen will also be connected to this carbon. So you will have something like this kind of chain, and this side also you will have same thing. So now how many CH2 group you have? This is a CH2 group, CH2, 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 CH2. This is not a CH2. So you have 5 groups here and 5 from this side, 10, 11, 12, 13 and 14. So 14 CH2 group we have. And how many oxygen atom? 1, 2, 3, 4. So 4 oxygen atom. So in total the answer is 14 because you have to give the sum of these two numbers. So I hope you like these videos, and if you like, please share with your friends, like on my channel and subscribe to my channel. I will see you in the next video. Thank you.